Algebra 1, Factor Polynomials. In this concept, we're going to focus on polynomials with the greatest common factor and ones that have a special factoring pattern called a difference of squares. This entire unit is on factoring polynomials, however, and over this unit you're going to learn a process on how to look at a polynomial and identify what exactly you need to do to factor it. So what is factoring? Well, when we factor in math, we are finding the multipliers. So that's where I started with these examples. I have given you some multipliers. So let's go ahead and multiply these together. So we'll start with simple numbers, 5 times 8. So when you multiply, you get 40. Now factoring is thinking backwards from multiplying. What can I multiply together to get 40? Well, we could do 5 times 8 again, or 40 has other factors, 4 and 10 for example. So the word factor can be used as a noun or a verb. So we say that these right here are the factors. When we also say when we break apart 40 into numbers that will multiply to give you that is called factoring. We have factored that. Let's look at the next example with a polynomial. So again, I have two multipliers. So the polynomial, it's a monomial, 4x, times this trinomial. So when we multiply, we have to distribute that 4x. Minus 28x. So we have multiplied those two together. Now in this unit, we are going to learn a process where you work backwards. Start here and then you factor out, divide out a common term, multiplier. Alright, lastly I have two more different kind of multipliers. So these are binomials. Now you have learned how to multiply them using a 2 by 2 square. Another method is just to distribute. And you have to distribute everything in the first expression by everything in the second. So there's a little acronym that will help you do that, and that's called FOIL. So the F stands for multiplying the first terms together. So the x times the x. The O stands for multiplying the outer terms together. So that's on the outside of both. I stands for inner. And L stands for the last terms in each expression. Nothing magical about FOIL, but again, it's just an acronym to help you remember when you have a binomial times a binomial, how to get everything multiplied together. So when we combine like terms, we get x squared minus 4. So that's when we've multiplied. But remember, in this section, we're going to learn a process for how to start with something like x squared minus 4 and work backwards to the factors. We will learn to factor the polynomial. Factoring polynomials is a process. There are many different types of polynomials. If you go through each of the steps of the process, you will exhaust all the different ways that you could factor your polynomial. So the very first thing you need to do when you get a polynomial is you need to factor out any greatest common factors. In math, we call these the GCF. Now with polynomials, remember a greatest common factor could involve a number value, but it also could involve a variable power as well, and sometimes it involves both. Step 2 is then you will examine the number of terms in the remaining polynomial, and then based on how many terms there are, and we're going to talk about 2 and 3 terms in this unit, will determine what you do next as far as factoring. Let's learn each part of the process of factoring, and let's start with step 1. Step 1, we're going to look for greatest common factor. So get down the definition of greatest common factor. Pause the video if you need to. A greatest common factor is the greatest number and or variable power that divides into each term of the polynomial that you're working with. And I have an example for you. In the polynomial 3x cubed plus 12x squared plus 9x, if you examine just the coefficients 3, 12, and 9, the largest number that divides into all three of those evenly is 3. If you examine the variables x cubed, x squared, and x, the largest number of variables that are in the terms without going over is just a single x. So the greatest common factor that divides into each of those terms is 3x. Now let's look at these first four examples. So example number 1 says factor 15x cubed minus 10x squared plus 5x. So we're going to start with step 1, where we look for a greatest common factor. So between 15, 10, and 5, the biggest number that divides into those three numbers is 5, and we write it out front. Between x cubed, x squared, and x, the most variables that we can divide out without going over the power of any single term is just x to the first power. So we factor that out to the front. Now we draw parentheses and we write what we have left once we have divided each of these terms by 5x. 15 divided by 5 is 3. X cubed divided by x is x squared. Negative 10 divided by 5 is 2. X squared divided by x is 1. 5 divided by 5 is 1. X divided by x is also 1. So we have factored this polynomial by completing step 1 of the process, factoring out a greatest common factor. Example 2, we have 3x to the 4th minus 12. So start by looking at your numbers. The biggest number that will divide into 3 and 12 is 3. The most x's that you can divide out without going over any in a single term is 1. We open up a parentheses and then we write what we have once we've divided 3x out. 3 divided by 3 is 1. X to the 4th divided by x will leave us with x to the 3rd. Negative 12 divided by 3 is negative 4. X divided by x is 1. So we have factored this polynomial into two terms that can multiply to give you that original polynomial. Let's do a couple more. You're probably already answering the first question in example 3. The biggest number that divides into 5 and 20 is 5. The largest amount of variables that we can divide out without going over any single term is x to the first power. 5x squared divided by 5x will simply leave us with a single x. Negative 20x divided by 5x just leaves us with a negative 4. Alright, lastly, 2 and 9. The biggest number that divides into both of those is 1. But we don't need to write that out front, so let's move to our variables. The largest amount of x's, once again, that we can factor out is x. So sometimes our factor will be a single number, our greatest common factor. Sometimes it will be a number and a variable. Sometimes it will simply just be a variable. And then when we divide out an x from each of those terms, you write what you have left. You can always check and see if you have factored out a greatest common factor correctly. You can multiply back, distribute back, and see if you get what you started with. If you do, then you factored your greatest common factor correctly. Now look down to the bottom of your note sheet. Now we're going to add the next step of the process. So we don't abandon step 1. We always will look for a greatest common factor, but then we will add step 2. And step 2 is to examine the number of terms that you have, either in your original polynomial or what you have left after you've taken out a greatest common factor. And then in this concept, we're focusing on if there are 2 terms. if there are two terms, we're going to look for a special factoring pattern, and that's the pattern called the difference of squares. Now move up just a little bit on your note sheet, and we're going to get down what the difference of squares is. So next to difference of squares, we're going to write it in formula form, and then I'll help explain what this means. So a difference of squares would be if you had some term, monomial, we'll just call it A squared minus B squared. Well, that would factor, let's actually use an arrow. So that would break apart into the two expressions A plus B times A minus B. So whatever you're squaring first plus whatever you're squaring second times whatever you're squaring first minus whatever you're squaring second. So the question you need to ask yourself when you have two terms and you're looking for a difference of squares is, what numbers or variables can I square to get them? So if you look at x squared, you can think, oh, well, if I take x and square it, then that'll give me x squared. So that's my A term. Now we're going to ignore the negative. It's not part of the number. We're simply going to look at just the positive number 4. What number can I square to get 4? Well, that'll be 2. So now kind of follow this formula, if you will. Whoops, and we're not going to look at the left side of it. We're going to look over here at the right side. So x squared minus 4 will break apart into our A term, which is x, plus 2 times our A term minus 2. Now we can make sure that that's correct if we multiply that back together. So I'm just going to FOIL it. First terms together. Outer is negative 2. Inner positive 2x. So we do get what we started with. So this is a pattern called the difference of squares. Let's try it again. X squared minus 9. I have two terms. I have a difference. So what can I square to get x squared? Oh, that's easy. What can I square to get 9? I know you're saying it. 3. So now we know our A and our B terms, meaning what we had to square to get what we started with. So it will factor as x plus 3 times x minus 3. Next one, 4x squared minus 16. So getting a little more complex, but you can handle it. What do you square? So this will be our A term. To get 4, well, 2, and then to get x squared, x. What do I square to get 16? 4. So this will factor as 2x plus 4 times 2x minus 4. Now let's just do our A and our B term in our head. So what can we square to get 121? 11. And then to get x squared, x. And then what can we square to get 25? 5. And what we have there are the factors of all of these difference of squares. All right, now let's put steps 1 and steps 2 together. So in example 5, the first thing, step 1, we look for a greatest common factor. So the biggest number that I'll divide into 2 and 72 is 2. Largest amount of x's that I can divide out is a single x. So what I'll have left is x squared minus 36. Now I look at my polynomial, what I have remaining. It is two terms, and so I look and say, well, is it a difference of squares? Sure, because I can square x to get x squared. I can square 6 to get 36. So I simply bring down that first term, and then I set up my two sets of parentheses, x plus 6 times x minus 6. So all of these three things, if we multiplied them back together, we would get our original polynomial. Example 6. What is the largest number that I'll divide into 4 and 100? 4. I'm left with x squared plus 25. Now, I do have two squares, but this is not a difference. So this is not a factoring example where I can use that pattern. So I'm done. That's all I can do with this one, because I don't have two polynomials that I can multiply together that will give me x squared plus 25. This is what we call prime, that expression. Number 7, the biggest number that'll divide into 218 is actually 2. And we'll be left with 100x squared minus 9. Now look at that remaining polynomial. See, it's a difference. So look for a difference of two squares. And you've got it, because you can square 10 and x to get 100x squared. You can square 3 to get 9. So we'll bring our 2 down, because that's part of the factor. And then we'll write 10x plus 3 times 10x minus 3. All right, last one. Example 8, x squared minus 81. The biggest number that'll divide into both of those is 1. There's no common variables, so there's no greatest common factor. So we just move to step 2. It has two terms, so we're going to look for difference of squares. And we've got it, because we can square x to get x squared. We can square 9 to get 81. So this will factor as x plus 9 times x minus 9. This last part is practice and also your teacher talk. Work all 6 of the problems using the step-by-step process. So factor out a greatest common factor, and then look and see if you have two terms left. If you do, see if you have a difference of squares and continue factoring. Then when you're done with those 6 problems, go to your teacher talk and check your answers with the teacher. Any problems that you got incorrect or have questions on, you can go over. Then you'll move on to the Math Excel practice and take the quiz.